Hello everybody, welcome back to Planet X News, July 12th, 2021. Hey, listen folks, if you caught my last video, we talked about some of this wild and crazy weather. Some of that weather, heavy downpours, torrential rain, wind, landslides, I mean, you name it. It's occurring pretty much all over the United States. And also these very extreme heat temperatures. They're massive out west. But anyways, so that was a couple of days ago. And now, it has happened again. Now, a couple of days ago, it was in the Pittsburgh area where I live. Now, this time, these massive storms just popped up out of nowhere and devastated the Philadelphia area. And I got a phone call today from some friends of mine that actually live in Philly, and another friend of mine that lives right across the border over in New Jersey. Both of them said that they have never, in their 50 plus years of living in these two cities, in these two states, right next to each other, they've never heard thunder crack so loud that it literally shook windows, shook buildings. And in Philly, they got some places, I believe, up to 4 to 5 inches of rain. And then the same thing happened right across the border over in portions of Jersey. I'm going to show you some information from this storm system that went through there. Also, at the same time, as I showed you in my other video the other day of the subway systems in New York City flooding instantly and people being trapped down there in waist high water. Well, the same thing just happened over in London today. Subways filled with water, massive storms just popping up right over London. So, I've been a weather watcher, I don't know, ever since I was about 19 years old. As soon as I moved to Miami to go to college, started to experience, hurricanes and some of the heavy downpours, tropical downpours that they have there. So, I just had a fascination with weather, started learning a lot from the Hurricane Center there in Miami and so on and so forth and blah, blah, blah. So, I just had this, fascination with weather. So I've been watching it ever since. So that's been quite a long time. And, what I'm seeing is just this very, very, what seems to be like a kind of a weird, in my eyes, this weird heating up of the atmosphere. And it's kind of unusual. The weather that I'm talking about, these massive heavy downpours, 3, 4, 5, 6 inches of rain just dumping out of the sky, the massive amounts of lightning strikes, and also the sound of this thunder. Now, look, we've all been through rainstorms, thunder and lightning storms. We all know what it sounds like. But listen, I'm telling you right now, the storm that rolled through here in the Pittsburgh region the other day shook my house. When the thunder cracked, it shook my house. And my friend that lives over in New Jersey, right across the border, right across the bridge from Philly over into New Jersey, she lives in a townhouse area, and she said the same thing. Literally in her kitchen and cooking something to eat, and ba-boom. And she's got sliding glass doors and a small little balcony. She lives on the second story of this townhouse community. And she said the sliding glass doors, she visibly saw them shaking and rumbling, and it wasn't from the wind. It was from the percussion from these clacks of thunder. So, look, we've all had strange weather from time to time. But what I'm trying to draw my point to is the consistency and this very, very fast heating up of the atmosphere. And I'm going to go ahead and show you, but first I wanted to show you what happened over in these two cities. We're on Twitter over here. Brittany Boyer, she works for Channel 6 ABC. She is a meteorologist, and this is just posted by her about 2 hours ago. And this was the storm that came through. So you can see Philadelphia here. You can see how massively intense this was. Now, my friend lives over here in Mount Laurel. So that's right across from Philadelphia. And, you know, both sets of friends told me about their experience. And they've lived in Philly and Mount Laurel, New Jersey, their whole entire lives. Okay, so they've seen all kinds of, weather. But today, they've never seen anything like what they heard and saw and went through today. Even when hurricanes or the remnants of hurricanes have washed up the eastern seaboard and, kind of splashed around, and, Philly got some remnants, and, Jersey got some remnants, and yeah, they may have gotten some flooding. But this 5 and 6 inches of rain is crazy. So if you read this meteorologist's words, slowly moving away, the heaviest rain is now pushing eastward from the hardest hit areas this afternoon. We are still seeing heavy, very heavy rain in parts of northwest Camden, Burlington counties. And then her link to track it on the Doppler. So I'm going to go ahead and just go back here and take a look at this post, and this was about 3 hours ago. They were talking about 1 to 3 inches possible. Then things changed. Water rescues in lower Bucks, and I guess that's Bucks County, and northwest Burlington County. No travel advised. 4 to 7 inches of rain so far. 4 to 7 inches of rain. Now, folks, this wasn't like this rain accumulation occurred over a period of a couple of days. This was straight up over the course of, I think, about 2 hours. So you can see right here, this is from the National Weather Service, and she also posted this. And this shows you the wide swath of flash flooding. And that flash flooding, man, I mean, that's dangerous. That's when things get really, really scary. And if you don't know what's going on, and I don't know, if you don't just have your wits about yourself, hell, let's put it this way, you could end up dead. Let's take a look at another one of Brittany's posts here. Flash flooding continues in parts of lower Bucks and northwestern Burlington. Radar estimates now showing over 5 inches in spots near Bristol and Bordenton. So, man, look at that. I mean, that's crazy. We got similar heavy downpours around here. And we are a little more hilly or mountainous over on my side of Pennsylvania. So we had quite a few mudslides, landslides, hill slides coming down. There are trees on these hillsides. They get uprooted, and next thing you know, these massive trees are falling down off of these hillsides and crashing down over roadways. And that can happen, and in a heavy downpour beating down on your car, you're not going to hear a massive 60-foot tree coming down. You're just going to feel it crush your car. So we saw quite a bit of that. This was just another post of hers. This was 5 hours ago, and I guess this is when they were kind of waiting for it, and it was coming, and then sure as hell it came. Now, what I was reading some of her other posts, and she was talking about this very, very fast heating up of the atmosphere, and that's naturally how you get these large and loud storms. But look at the temperatures. This came out of nowhere. So it was blazing hot here in the Pittsburgh area 3 days ago, and that storm front went away. Well, this is not the same storm front. These are not the same temperatures as a couple of days ago. This is once again the atmosphere just heating up. And look at these temperatures, 102, 101, 100 degrees in Philadelphia. 99 degrees right there in that Millville. 98 in Lancaster. 99 in Reading. I mean, usually, folks, we're just like, in the mid to high 80s. Crazy. And this heating up of the atmosphere, which it's just not over Pennsylvania. It's everywhere. It's all over the entire northern hemisphere. And remember I talked about the Earth wobble, and during this wobble, as it gets worse, the Earth, the northern hemisphere, during periods of the rotation around the sun, we're actually going to be pointing a little closer directly towards the sun. So, that's our change of seasons. But never like this. So, what is next summer going to look like? Now, on the reverse order of all of this, we have winter. So if we're seeing these extreme temperatures here in the northern hemisphere, then the opposite of it is extreme cold. So, wow. I mean, this seems to be happening very, very rapidly. You know what I mean? The change. I mean, I know we've seen some change over the last couple of years. And I chart this weather, and I watch this weather, and I remember what happens year after year, But anyways, let me show you what I'm referring to about this instant, very, very fast heating of the atmosphere. So as the wind currents are going by, you're getting moisture because of the jet stream that's getting sucked up. Let me just expand this backwards here. You're getting this moisture that's going to be coming up from the Gulf of Mexico in this pattern, and all of a sudden that moisture that is in the air, it is all of a sudden superheating, just like radiation. It's just superheating these swaths of air. And let me show you what happens very, very quickly. And this is kind of out of the norm, I've been listening to these weather forecasters, and every now and then, I like to study like body language and their voice inflections. And some of it, they seemed very, very surprised and almost not knowing what to say. For instance, okay, why did this just happen? They really didn't have that much of a notice, like an extended forecast. So let's watch over here. Here's Philadelphia. And you see these reddish areas that are popping up right here. Okay. Watch these areas. I'm going to just put it in the middle of the screen here. And watch how fast this superheating occurs. And then all of a sudden, boom. So I got this on a widened view, but we're going to look at this again. We're going to look at it up close where you could see how fast an area, and if you're under one of these, you're going to see how fast you can get caught. Let me just back this up just a little bit. Okay, we got Philly right there. We'll go ahead and let this play out. You could also see the lightning strikes, the downpours. You can see the real reddish orange areas in the middle. And then bingo, look at the lightning up here. And then you'll see a huge patch of it right over here. And that was down around, in Maryland. I didn't even bother to go ahead and look at any Maryland weather, because I got the phone calls from some friends over there in Jersey and Philly, and they were telling me about what they experienced. But if you pan this back, you can see over in Ohio, right up here at upstate Pennsylvania, anywhere where you see these red splotches, that atmosphere heated up so rapidly that, even with the best meteorology programs, satellites, Doppler, whatever, these storms are superheating and they are dumping massive amounts of rain, which is unusual. 1 to 2, 1 to 3 inches of rain, okay, that's high. 5, 6, 7 inches of rain, that's crazy. That's absolutely crazy. If you pan back, now look, Louisiana this time of year, down in portions of Texas, yeah, they get some crazy storms. Same thing was occurring here. Real fast heating of the atmosphere. But it was just like it was, just kind of in sections. Now, again, you got a large body of water right here, a lot of moisture, so that tends to play into the development of these pretty harsh storms. So, basically in a nutshell, folks, I guess, be on the lookout, man. Don't take chances. Something is going on. Just let me get to the damn root cause here. I think that something is changing, and I think something is changing rapidly, and I just think that it's definitely far out of man's control. So I don't know. We're just about halfway into the summer. What the hell is the rest of July, August, and September going to look like? Hurricane season goes all the way to November 1st. The Atlantic has been, kind of quiet. There's not really that much to talk about. That one storm hurricane rolled through, really wasn't that much to talk about. But like I said, in this upper level of the northern hemisphere, let's take a look at London. And let's watch what rolls through London. Now, I saw a few video clips of people in those subways. Hold on, we're going to get all the way in here to London. We'll go ahead and back this all the way up. And again, could you imagine being in one of these subways? Look at this. You see how fast it developed? Right in the early afternoon. People, all over the place, everywhere. It's work, Monday, people everywhere, subways, cars, buses, whatever. And the next thing you know, you're not expecting this, and then wham, boom, bam, you're in major flooding conditions here. High winds and lightning, thunder, you name it. Temperatures are getting pretty crazy again. I have you over here at the Null School, and we're just going to take a look at this. And this was, I dated this back to early yesterday. And yes, around this time of year, portions of California are pretty hot. Well, let's just take a look at there. See right here in the left-hand corner where I'm circling? 115 degrees. 117. 114. Central Florida. Central California, 105.6. Moving up a little more in Central California, 115.8. A little bit further, 108.5. Now, I have a friend of mine. Her name's Kathy. She lives in Yuba City, right where my cursor is, somewhere around there. And she sent me a text message, and she said, "Scott, in my 54 years of living here in California," she goes, "never have I ever felt heat like this before." She said, "It's so intense that you can't even walk outside." I mean, these are very strange temperatures for this portion of California. What happened the week before? Well, all of Washington, Oregon, all of this area, parts of Canada, all over Canada. Massive, massive heat bubble that lasted for, I think, over a week, 10 days. It racked up a lot of casualties. A lot of people died. It's just very unusual. Some people may say, "Oh, well, it's just weather, Scott. It's just weather." Oh, really? Yeah. Okay. Well, your opinion is your opinion. But what I'm telling you is based on my research and what I chart and read and look at every day for years and years and years on end. What we're seeing is not normal. Okay? Not normal. Okay, dead center in the middle of the Arctic, 32.8 degrees. What I want to do here is I'm going to advance this, and let's see if that temperature goes up. Give me a second here. Went up 1 degree. So at the very, very tippy top of the Earth, you'd expect it to be a hell of a lot colder than, 32, 33 degrees. You see these swatches of green right here. That temperature's 35, all around Greenland. Look at little Iceland. 59, man. They're getting suntans in Iceland. 58. I'm sure this temperature went up probably a little over 60. There's 60.2. You could see everything right here in the lower left-hand corner. Yeah. What's it over here? 42. 40. 37. Well, that's the top of our Earth. You could guarantee if we were able to get a real aerial satellite view of what it looks like right there right now, there's probably no damn ice at all. Yeah. And again, you know, along this this longitude and this latitude, look at India, 117. So this is what I mean about this possibility of the Earth wobble. So now that I have this model up, I could show you what I mean. Okay, so let's just say this is the Earth's normal 23.5 to 25.5 degree tilt. Now I can't wobble this model, but what I can show you is if during this wobble, just that little bit, you see how I moved that? Just this little bit, and as the Earth rotates, it's wobbling. But you know, this, I'm doing this in an extreme manner. That wobble takes 365 days to complete one wobble rotation up here at the Earth's axis points. Okay? But if this is our normal tilt, if we were just tilted just a little bit more, and then as we rotate, the Earth rotates and faces the sun each day, what occurs? More direct sunlight on this portion of the Earth. Forget about from here to here to here to the equator. Forget about this area. From here to here to here, all the way to the top of the Earth. This section of the Earth, all the way around, is being tilted towards the sun in that wobble more. Even if it was 1 degree, that's just intense. So this wobble's been going on for a long time. It's actually gotten worse. It's increasing. You know, here comes the question. Okay, what's doing it? Is it naturally occurring? Nah, I don't think so. I'm not talking about, you know, magnetic pole reversals, and people were dropping comments about that, telling me I didn't know what I was talking about. I mean, I never mentioned magnetic pole reversals because that's not what we're talking about. Magnetic pole reversals is something totally, totally different, and that is also occurring at a very rapid pace. I'm talking about the rotation of the Earth as it wobbles on its axis like a top. Once again, that wobble takes 1 year, 365 days to make one circular wobble. During that period of time, the Earth is being exposed to more direct radiation from the sun, therefore heating up the atmosphere intensely. Hence the extreme temperatures that are absolutely insane, indicative of hell. And then these inductions of superstorms. I mean, that's what we just should call the damn things. Any storm that just pops up like that and dumps 5 to 7 inches of rain in a 2-hour period or even a 1-hour period is a superstorm. Something like that would be rare. But in 2020 and now in 2021, it's not rare. It's like damn near commonplace. So anyways, you know, I just wanted to share all of that with you because our weather is going to start to become a very, very main talking point. No doubt about that. But let's jump out of here. So you all know what's happening. And basically what I'm trying to do is I'm just trying to warn you. You know, pay closer attention to what's happening around you. You know, try to catch that weather. And with today's technology, look, man, you could get it on your phone, your computer, you know, watch the news, whatever. But, you know, try to start paying closer attention to it and just don't take any damn chances, you know. So we're going to go ahead and jump out of here. And I think tomorrow I'm going to be watching some of these areas again very, very closely. Something that I wanted to show you guys was some really intense coronal mass ejections that have occurred over the course of the last couple of days. We were able to get two pretty good Planet X captures, one on the western limb of the sun, and then 3 days later, as it catapults itself around the sun, we were able to catch it on the other side. But during that transition, going around the backside of the sun, wow, it created an A-class 9.3 flare. You see all these markings here? Well, these are all flares that started active regions on the sun, starting on the 9th. Let's take a look at this one here. This is on the cactus. This is very, very hard to extract data from because they only give you 10 frames, very low resolution. It is a pain in the butt to work with. Literally, whenever I try to extract photos or information from this, if I see something, you know, I have to download this, I have to turn this into 4K, and then we run it through that program. And whenever we're running the software with this cactus, it just takes forever to render a photograph or see something that's been, you know, kind of clouded in all of the interference and these coronal mass ejections. So I'm just going to move it slowly. See how far I have to move it? These frames are just like 9 to 10 frames. That's it. So that's what occurred on the 9th. Now, we weren't able to extract any data from cactus on that day, but we were able to extract it from another coronagraph. Oh, let's see here, up here on the 12th. Take a look at this. Now this, let me just back this up because, like I said, this is a pain to work with. Now, right here, we thought that we possibly recorded something, and unfortunately, it didn't come out. It could just be part of the coronal mass ejection, but it was kind of one of those false positives. But we did capture something right over here, but that was on another coronagraph with many, many more frames. This was like a double blowout. What you're seeing over here, right up here, there was the release of this 9.3, this A category 9.3 solar flare. It was pretty impressive. Now, I'm going to go ahead and jump out of here, but I want to show you guys these actual videos. So I'm going to move over here. We're going to pull this up. Is this the one? No, this is the one from the 12th. This is the one I want right here. This is the one from the 9th. And check this out. So you see where the blue square is in the gray image on the left-hand side. Do you see that ripple effect that occurs over this part of the sun? It literally comes up over top of the northern hemisphere of the sun. This explosion occurred way on the back side of the sun. But that's how powerful, that is how powerful that was to create that ripple effect up over top of, I would say, about, well, what, maybe 20% of the sun, the top portion of the sun, and coming from behind. So the view you're looking at is the view that we could see from Earth. So again, the power and the magnitude of that rolling over top of the sun. My point here, yeah, that's all pretty cool. But, you know, if things like this start to occur Earth facing, well, then it's a totally different ball game, folks. That's all I have to say. It's a totally different ball game. And you know, just like I keep saying, things are happening so rapidly, it's starting to boggle my mind. You know, just when you think that you have, well, not all of the answers, but some of the answers, and then you start to see things like this occurring when they really kind of shouldn't be occurring just yet. You know, moving into this solar maximum. It's a kind of a slow progression over the first 5 years. Then you have 6 years, you know, where things start to slowly filter off. So that cycle of the sun, solar minimum, solar maximum, is 11 years. But the strength and the frequency of these coronal mass ejections is what is alarming me. And how powerful. They're really freaking powerful. This is from the 12th today. You can see even more activity. Now, that is even further back because the sun has rotated just a little bit more, and we're rotating around the sun. But that blue square where you see that dark color, that is intensity. And once again, that was a Category A 9.3 flare, solar flare. Now, it wasn't an X flare, but it was still, the magnitude of it was super high, 9.3. Incredible shots, you know, interesting, you know, very interesting information. And that, you know, I'm glad that wasn't really, you know, facing our way. But I'm going to go ahead and jump out of here. And, you know, we could take a quick look at the CME tracker. And this will show you what I'm talking about. So here we are in the yellow. Here's the sun. And those explosions are on the directly kind of like the back side of the sun. Why are they occurring on the back side of the sun? Well, this is the time of month right in the middle, the 10th, 11th, 12th, 13th. This, you know, this stellar core object loops up back around the back side of the sun. And as it does, it is a very, very fast movement. Okay, because it's slowly coming up, and the sun just kind of grabs it, whips it back around. And in 3 days, with that type of orbit that it is now in, it's like a slingshot. So when it approaches and loops around the backside of the sun, it's almost like a slingshot. Sometimes we'll get multiple photographs of it on the western limb, or excuse me, the eastern limb of the sun. It all depends. It all depends on the cameras. If they snap that photograph, that one frame at that perfect timing, we'll catch it. Well, we got it today, and I'm going to show you those. But you could see the massive explosions, and there were two of them. One, two. You could see them. And then they just literally merge together and move off into space. Now, could you imagine if something like that was directed straight towards the Earth right here? And eventually, it's going to happen, you know. But I wanted you guys to check that out. Now, getting into what we captured. This was on the 9th. Check it out. Check it out. Incredible. Now, that was, you know, in the kind of the beginning phase of all of what I just showed you. So let's take a closer look. And this was a pretty powerful CME that occurred here. This was a doozy. And this is what I mean. You know, when this object is in its orbital path around the sun and it gets close enough to the sun, it is my hypothesis that the two magnetic fields start to literally collide. And what does that do to the sun? Because the sun is a star and this object is not. The sun reacts by expelling its material, plasma, coronal mass ejection. This object then moved upward here, and what did we see? Several days later, as it's catapulting around the sun, bam! We see that massive explosion listed as a category A 9.3 solar flare. As it makes its way, catapulted around, by the 12th, it's over here, and what occurs? The same damn thing that you see here, but it occurs here. I hope you guys are getting that. Here is the blown up version of what you guys just saw, and you could see the extensive rays of plasma just literally ripping across the surface of this object, and it is in the prime time area, almost at the sun's equatorial region, as I've mentioned before, at the equator of the sun. And that is all due to the very acute inclined orbital path that this object is stuck in. It's pretty interesting. I mean, it's it's pretty crazy. Let's just put it that way. Here are negatives from the July 9th visual that we got. Just a little closer. And full blown right up in your face. Yeah. Interesting, isn't it? Yeah. So anyways, getting back to, okay, this was on the 9th. I got these pictures a little jumbled up because of the way that they came in. So here's the 12th. And this is where things got really interesting, because that explosion on the sun really rocked the SOHO satellite spacecraft that takes these photographs. And it rocked it pretty good. And that's what, 93 million miles away. So it was pretty intense. But as I mentioned, we had the object here on the 9th. it catapults around. You had the coronal mass ejection here on that side on the 9th. It moved up this way. It created that massive flare, 9.3 on the backside, and here we are. It's being catapulted around, and then as it starts to move away, it will slow down. And you know, my hypothesis is that it moves all the way below our solar system, and then it scoots its way right back around, and that takes about 28 days is what I've calculated, and that was about 3 years ago that I started that calculation, and it took me 3 years of sightings and writing down dates, times, the whole 9 yards to try to figure that out. So it's been about 3 years since I came up with that 28-day orbit. Now also, at the same time of spotting this object in this 28-day pattern, from time to time, we were also able to capture other objects trailing with it. But that only depends on the quality of the photographs, the data that we're able to extract, and just pure damn timing of when the shots were taken. You know, we'll zoom in on this, and you can see it. Now, it's a little grainy. It's not as sharp as the other. Reason being is because it is a little further back behind the sun. And if you take into consideration, you know, the how big the sun is, what is it, like 862,000, what is it, 865,000 miles from, you know, in diameter. So this is a little bit further back behind the sun, right where I showed you on the CME tracker, back behind the sun where those waves of energy were blasting off from the coronal mass ejections. Because we're looking at a two-dimensional photograph, it looks like it's left, right, left, right. People ask me that all the time. But I'm not showing you a three-dimensional photograph. I'm showing you a two-dimensional, flat, one-dimensional. So there's no depth in the photographs. That's just something that you guys are going to have to understand. I wish I could show you depth, but we can't. The data just doesn't allow us to do that. So we move to the negatives. You know, bingo, right there. But it's further back. You know, exactly how far, I don't know. But it's further back behind the sun, and its rotation is bringing it this way now. So it started out coming up this way. It loops around the back side of the sun. How far out it goes, I don't know. But it must be very close at the back side of the sun in order for that catapulting action to occur. And then phew, it just goes. And then it's out of our sight. This brings you a little more up close. And again, like I said, little hazy simply because it is further back. Now, we did think that we spotted something right here. There's kind of a weird shape right there. Ran the data twice just to make sure, and this was just absolutely nothing. Some type of anomaly in the photograph, you know, anything coming from the sun. It was a pretty strong coronal mass ejection. So that's what I've got for you folks. Some really weird weather. Some pretty damn good photo captures in a 3-day span showing this object moving from the western limb of the sun as we see it around the top, creating a magnitude A 9.3 solar flare multiple coronal mass ejections on both limbs of the sun, and then rotating around, orbiting around and up and over the sun. And then July 12th, we get it on the eastern limb of the sun, and we get a pretty damn good photo capture of it. So that's what I have for you folks. Getting back to that weather, just pay attention. And as far as these massive amounts of heat, watch your little kids, watch your kids. You know, we talked about that sunburn. You know, my friend and his wife and the kids, man, they're suffering like dogs, man, with that severe sunburn and sun poisoning, blisters like hell. So just pay attention, and do me a favor. Make sure you're subscribed. I'm getting emails from folks telling me that they're finding themselves getting unsubscribed. So I don't know why that happens. But just make sure you hit that subscribe button. Check that. Check your notifications. And share this video. And again, keep in your mind to watch this weather in this northern hemisphere. Watch it closely. You never know. Your life may depend on it. This is Scott from Planet X News. Thank you for watching. Be safe out there, folks. Take care.